In this video, we are going to take a look at factoring trinomials, so 3 terms. This is the main one that we use the most often. And I've got the steps here, and I'm going to follow them through, but you may want to follow the examples first and then come back and write them so that they make more sense when you come back and write them and take those formal notes. So first you're going to be in standard form. All of my examples are already in standard form. You're going to multiply a times c, so that's your leading coefficient with your constant term. And then you're going to find factors of AC that add to B. Then you're going to draw the box, place the first and last terms in the first and last boxes, and then the two numbers that you picked in step 3, you're going to put in the middle boxes. And then you're going to factor by grouping. So this is all going to make a little bit more sense as we start to do the example, starting with this first one, 2x squared plus 13x plus 15. So we're going to start by multiplying a times c. So 2 times 15 is 30. And then I'm going to look for factors of 30 that add to 13. 13 is my b, right there in the middle. So if you see 10 times 3 right from the start, you can do that. If not, you can start with 1 times 30. That doesn't work. 2 times 15, that doesn't work. 3 times 10, that's the one that works. 3 times 10 is 30. 3 plus 10 is 13. So 3 and 10 are the two numbers I'm going to use. By the way, I should mention my signs here. I'm multiplying to a positive and adding to a positive. So they're both going to be positive. I am going to draw the box. I am going to draw the box. That's my dog asking for dinner. I'm going to place the first box in the first one, or the first term in the first box, constant term in the last box, and then I'm going to use the 3 and the 10. But be careful, remember what I'm trying to do is add to 13x. So it's going to be 3x and 10x. So let me make the point here that my trinomial, 2x squared plus 13x plus 15, and what I have in the box are equivalent. 2x squared plus 13x, 10x plus 3x is 13x plus 15. So I've not changed my problem, I've just changed the way it looks. Now I'm going to go each row, each column. So looking in this first row, or first column rather, 2 in common and x in common. And in this second column, whoops, right there, 3 and 15, 3 is common, no x. And then in my first row, 2x squared and 3x, they just have an x in common. And then 10x and 15, they just have a 5 in common. I can remultiply. 2x times x is 2x squared, 3 times x is 3x, 2x times 5 is 10x, 3 times 5 is 15. So remember, to get your answers, you're going to go right here and right here. And order matters. If the 2x plus 3 is on the top, they go together. So you can't do 2x plus 5, that would be wrong. And then x plus 5. If you remultiplied, you would see that it does, in fact, work. So that's my answer right there. All right, let's go to the next example. I have 5y squared minus 24y minus 5. Again, I'm going to start by multiplying the first and last. 5 times negative 5 is negative 25. Signs are important. Signs are important. So I want to multiply to negative 25 and add to negative 24. So before I do anything else, I'm going to go, okay, negative 25, I'm multiplying to a negative. So I know I'm going to have one positive, one negative. Since I'm adding to a negative, my bigger one's going to be negative. And it's going to go right from the start, 1 times 25. So positive 1 and a negative 25 are the two numbers I'm going to use. I don't even need to keep going. Only 5 times 5 is the only other option. But I don't need to worry about doing it because I've already got the two numbers I need. So 5y squared goes in the first box, negative 5 goes in the last box. And again, I'm going to use the 1 and the negative 25. And again, it's adding to negative 24y, so I need the y's there. So my trinomial, 5y squared minus 24y minus 5, is equivalent to 5y squared, and then negative 25y, and 1y is negative 24y minus 5. and then I pull out the GCF. So first column, they have 5 in common and y in common. The 1y and the negative 5 just have 1 in common. 5y squared and 1y just have y in common. Negative 25 and negative 5 have a negative 5 in common. And I'm going to point out again, if this is negative, this will be negative. Here, this is positive, so this is positive. So I'm going to get 5y plus 1, y minus 5. 5y plus 1, y minus 5. That's my answer. Let's do another example. Okay, start by multiplying first and last. Remember there's a 1 there. So 1 times 20 is 20. So I'm multiplying to 20, adding to negative 12. I'm getting the negative 12 from right there. It's my middle term. And again, I can think about my signs. I'm multiplying to a positive, so my signs have to be the same, because that's the only way to multiply to a positive. Since I'm adding to a negative, they're both going to be negative. Looks like a little sad face kind of a thing. But negative, negative is what that says. So we have 1 times 20, 2 times 10. That's going to be the 1. So negative 2 and a negative 10. Because negative 2 times negative 10 is 20. Negative 2 plus negative 10 is negative 12. Okay. My Word document keeps messing up on me. So hopefully it won't do it again. And it's not letting me ink. Okay. So I'm going to draw the box. My daughter's now drawing next to me, so if you hear extra noise, that's all that is. First box is t squared. Last box is 20. My two numbers are negative 2 and negative 10. And again, I want them to add to negative 12t, so I'm going to put the t in there. Pulling out my GCF, t in common, 2 in common since it's negative, negative 2. T in common, 10 in common since it's negative, negative 10. So I'm going to get t minus 2 times t minus 10. Now, I want to point out a little shortcut that can help you. When your leading coefficient is 1, these two numbers that you choose here are going to be the two numbers that end up here. So you can skip the whole box step when your leading coefficient is 1. Only when your leading coefficient is 1. Okay, taking a look at our next example. And final example. We have 3x squared plus 9x minus 84. Now, the first thing that I notice, 3 times negative 84 is going to be a huge number, so I'm going to glance over and I notice that I can divide everything through by 3. Everything's divisible by 3. So before I do anything else, I'm going to pull out that 3. So 3x squared plus 3x minus, and that's going to go 20 with 2 left over, 28. Now that makes it a lot easier, because now when I go to factor, I can do 1 times negative 28. So I want to multiply to negative 28, and I want to add to 3. Thinking about my signs will be different, because I'm multiplying to a negative. Since the 3 is positive, my larger one's going to be positive. So let's start with 1 times 28. No, that doesn't work. 2 times 14, that doesn't work. 3 doesn't go. 4 times 7, that's going to be the 1. Negative 4 and a positive 7. Now remember what I told you in the last one? When your leading coefficient is 1, the two numbers you choose are going to be the two numbers that end up in there with your x. So x minus 4, x plus 7. Notice the 3 stays, because if I'm going to use equal signs, that 3 needs to be there. I don't get to just divide by 3 and throw it away, because I'm not solving an equation, so I don't have two sides to do it. So I need to pull out that GCF instead. And then that's my final answer. This actually probably could belong in the next video, or the last video, which is factoring completely. But it's good that we saw it here so that I noticed I didn't have to do 3 times 84 and deal with that gigantic number. So anytime you get a gigantic number, think, oh, can I pull out a GCF? Okay, that is factoring using the box method for trinomials. And again, that's the one you're going to use more often than anything else.